Hello guys, welcome to another video. On this one we're doing question 2 of June 2024 grade 12 exam. So the statement here reads that block M of 10 kg is connected to block small m of 2 kg with a rope T of negligible mass over a frictionless pulley. Both blocks are at rest. The slope makes an angle of 30 degrees with the horizontal. Friction on the slope cannot be ignored. And here guys, we see that our object happens to be on an incline. Okay, if the object happens to be on an incline, this is what we need to remember, that the normal force, just remind you here that the normal force in this case would be equal to Fg perpendicular. Every time the object is on an incline, this is what the normal force is equal to, and Fg perpendicular is equal to mg cos theta. It's important for you to have this knowledge in case you need to find the normal force. All right, and we also know that on an incline we are supposed to have another force, which is Fg parallel, and Fg parallel is going to be equal to mg sine theta. This is what you need to know, because we know that if an object is on an incline, it's supposed to have component forces, which are component forces of what? Gravity in this case. All right, so these are the forces that we have, although it may seem as though they are not there. Okay, now let's get into our questions. On our questions, they're saying define the term normal force. If we define the term normal force, we'll say that normal force is a force or a component of a force that is exerted by a surface on an object, right? That is exerted by a surface on an object which it is in contact and it is perpendicular to the surface. That's how we define normal force. Normal force is a force or a component of a force exerted by a surface on an object which it is in contact and is perpendicular to the surface. That is how you define it, guys. I can't write it, but if you want to write it, check your exam guideline. Also, just pause the video and write it as I say it, please. Now we go to 2.2. 2.2 says draw a labeled free body diagram of all the forces acting on the 2 kg mass. This is the 2 kg mass, and we see that the 2 kg mass is a hanging object. So when you draw the free body diagram for hanging objects, we already know from the number of marks that we are supposed to have 2 marks. So the first force that we are going to have is an invisible force, which happens to be the force of gravity, and the second force that we are going to have is the visible force, which happens to be tension. And this is how our free body diagram is going to look like. Okay, done and dusted with 2.2. This is 2.2, and then we move on to another question. Another question is 2.3. It says calculate the frictional force needed to keep the blocks at rest. The frictional force needed to keep the blocks at rest. So for this one, guys, we will use both objects to do our calculation. I'm gonna do for object A, this mass, for mass capital letter M. First of all, guys, they are saying the object is at rest. That is crucial information. If the object is at rest, it means there is zero acceleration. So F net is equal to MA will have to be F net is equal to 0. Okay, that's what we have to know about this, because our acceleration is 0, and we will use this formula to do our calculation. And for object M, capital letter M, or the 10 kg block, we need to see how many horizontal forces are acting on this object. Can I just fix here? How many horizontal forces are acting on this object? I'm gonna just quickly show those forces. So guys, the first force that is clearly visible is that of tension, right? But there's also another force that is not here, and that force is the component Fg parallel is also acting on this object. Okay, it's also acting on this object, and since this object is at rest, it means the main force, it's at rest, it means there's no applied force. So there's one force that's trying to get this object to move, and that is the force of gravity, and in this case it's the gravitational component force. Okay, and if that's the case, it means the object actually wants to move downwards due to gravity, and because the object wants to move in the downward direction, friction opposes the direction of motions, and it does so by doing what? By moving in the opposite direction. So our static friction here has to be in the upward direction because it's opposing the direction of motion, which is downwards, and that motion is due to Fg parallel, trying to pull the object downwards. I hope guys you understand that. Now when we look at the directions, we will say that maybe these two forces are moving in the upward direction, so they'll be positive, and then these ones will be moving in the downward direction, so they'll be negative. So this one will be negative, and then these ones will be positive because they are moving upwards. I hope guys this makes sense. Or we can do it vice versa. Let's do it vice versa by actually saying, because the object is trying to be pulled up, downwards will be positive and upwards will be negative. I think we can also do that, but even if you do it vice versa, it's okay. So now we will say that our forces are Fg parallel minus T minus Fs is equal to 0, right? And then we'll expand here. When we expand, Fg, I've already said that Fg is equal to mg sine theta. So that's what I'm going to substitute, but without putting the values. My m in this case is 10, and g is 9,8, and then I'll have sine 30 degrees minus t, I do not know what t is at the moment, minus Fs. I also don't know what Fs it is at the moment, and that will be equal to 0. This is my equation 1. And then I'm going to move on now to find information about m. M is as follows. We already drew the free body diagram. We know that this is T and this is Fg. Now here you will realize that the tension is moving in the positive direction. It's moving this way, right? It's moving this way. So it's moving in the positive direction, but the gravity is moving this way. It's going this way downwards, so it's moving in the negative direction. So that means here the forces that I have are T minus Fg is equal to 0. From this formula, I'm obviously working with the forces that are acting on these objects, which happen to be horizontal for this and this one vertical, and T is unknown minus, but I do know what Fg is. Fg is equal to mg. So here I'm going to substitute by 2, which is the mass of m, and 9,8 is equal to 0. Then this one will be transposed to the other side. I'll have T is equal to 2 times this will give me, obviously I'm going to get a negative value this side, and then when I take it to the other side, it's going to be a positive 19,6 newtons. So this is my force, right? This is my, this is my tension force. Now that I have this tension, guys, what I'm going to do is to substitute it here, and it will help me find my friction. I hope you're following me so far. So I'm just going to do my calculation. Let me firstly multiply here and find out what is 9,8 and sine 30. Alright guys, so when I calculate this, the value I'm getting is 49. I hope that's what you got as well. And then I'll say minus T. T is this tension. So I already know my tension. I found it from this second equation. And that means my tension in this case is going to be negative 19,6 minus Fs. All of this will be equal to 0. And then what I'm going to do is to say 49 minus 19,6. Okay. And yeah, 49 minus 19,6 should give me 29,4 minus Fs is equal to 0. And then this I'll transpose to the other side. I hope you are with me. I'm just going to write that here. I'll have negative Fs is equal to negative 29,4. And if I divide by negative on both sides, my Fs will be positive. So Fs will be positive 29,4 newtons. And the direction is obviously in the upward direction. Yeah, if we were to write the direction. But yeah, that's how you basically do the calculation, guys, for what is it, 2.3. yeah. Okay, now we are looking at 2.4. 2.4 says the rope snaps above mass M, causing block M to slide down the slope and block M to fall to the ground. The kinetic frictional force between the block and the slope is 25 newtons. Ignore the mass of the rope T. Now, this means that if the rope snaps, we will no longer have tension. And you have to remember, guys, that initially this object was at rest, but I said that there was a force trying to get this object to move, and it was the force of gravity, which is Fg parallel, right? And then this means that once this object, or rather this rope snaps, this object will definitely move now, right? And that's what they are telling us here, that the object now slides down. And if it slides down, what's making it to slide down? Because there isn't any force applied here. It is that component force of gravity, which is Fg parallel. And if the object slides down, where is our friction gonna go? Friction always opposes the direction of motion, so friction is gonna move in the upward direction, and this time the type of friction we'll have is kinetic friction. I hope you understand that, guys. Now they say draw on 2.4.1 they are saying draw a free body diagram of all the forces acting on mass M. 3 marks. How many forces are there? These are the number of forces. Firstly, we are going to have the force of gravity. Remember, we never show the component of gravity. No, we show the actual gravity, and it always acts in the downward direction. This one we don't show. This one we only show for the purpose of calculations. Please make sure that you understand that. This one only works for calculation, but on the free body diagram we don't show it. And then we will also have our force of friction, F, or I can say Fk. Since my object is moving, it will have kinetic friction. What's the third force? The third force is to be the normal force. Remember that the normal force is to be perpendicular to the surface. That's why it's facing this way. It has to be perpendicular to the surface. I hope you are with me on that. So this will be my normal force. So my forces are 1, 2, 3. I get my 3 marks. Please make sure that you don't lose marks, guys, when it comes to this type of question. Drawing a free body diagram should be a piece of cake. Let's move on now to the next question. The next question says we have to calculate the magnitude of the acceleration of mass M. Where are we going to get acceleration? We can get acceleration from equations of motion, but we can also get acceleration from F net is equal to ma, because in this case we are dealing with Newton's laws, right? And we are dealing with an object that is having certain forces act on it, getting it to move, and the object accelerates in the direction of the net force and all of that. So the net force definitely is the force that gets the object to move, which is Fg parallel. So Fg parallel is bigger than Fk. So thus we use this formula here, Newton's second law formula, and our F net is the mass, or is the sum of all the forces that are acting on this object. But which forces are we talking of in this case? The horizontal forces, not just any forces, but the horizontal forces. And for us to find those forces, this is how we will do our calculation. But I think the information we have is that the kinetic frictional force is 25 newtons. I thought they didn't give us this. So we will do our formula. We'll say Fg parallel. Obviously Fg parallel will be positive since it's moving in the direction of motion, and Fk will be negative since it's opposing the direction of motion. So Fk will be negative, and all of this will be equal to ma. I'll substitute now. Say, what is my Fg parallel? I already talked about this, guys. I said it's mg sine theta, but I'm not gonna write mg sine theta. I'm just substituting. M is my mass, the mass of the 10 kg block, and g is 9,8. Then I'll have sine theta. My theta in this case is 30 degrees minus 25. 25 is my kinetic friction, is equal to ma. M is 10 and a is my acceleration. From here, guys, I can simply just divide by 10 on both sides. Then I'll put all of this on the calculator. 10 times 9,8 sine 30 degrees divided by 10 minus 25. Okay, should be minus 25 over 10. So this is how it should be. You put it on the calculator as it is. We know that this side acceleration will cancel. The tens will cancel. So a is going to be equal to, when we put this on the calculator, we get 2,4 meters per second. There we go. That's our answer. And they said we must find what? The magnitude. We know that acceleration is a vector, but since they said find the magnitude, we need not worry about direction. But that's how you answer this one, guys. Hope it's making sense. Now we move on to 2.5. 2.5 says block M takes 0,5 seconds to reach the ground. Then they say calculate the final velocity of block M. Calculate the final velocity of block M. If you remember, block M was hanging, and then suddenly the rope snapped. And if the rope snaps, it means this object now got to move towards the ground, and this means it dropped from wherever it was hanging to the ground. And if that's the case, it means the initial velocity of block M, small m, was equal to 0 because it was dropped from a certain height and then it went down. So for us to calculate the magnitude, I'm looking at the wrong one. For us to calculate the final velocity of block M, we will use any of the equations of motion, but the ones we use have to have time, they have to have initial velocity and the velocity that we are looking for, which is the final velocity. The formula that is coming to mind for me is Vf is equal to Vi plus A delta T. Vf is what we are looking for. Vi is the initial velocity, which is 0, and acceleration is going to be 9,8. You also have to notice that, guys, this is an this is more of a VPM question, and that means we have to consider direction when doing this calculation. So we are taking downward as positive in this case. Thus my acceleration, which is a constant, is going to be a positive 9,8. What about my time? My time is given here as 0,5 seconds. So I'm just going to substitute it there and then just press the calculator to get my answer. Put everything on the calculator here, and if I put this on the calculator, that means that my Vf is going to be equal to 4,9 meters per second. And this is my answer basically for 2.5.1. Hope, guys, it's making sense. Now we move on to 2.5.2. They are saying here, how would the final velocity of M be affected if the mass was doubled and it is dropped from the same height? Right? Only increase, decrease, or remain the same. Explain the answer. For us, guys, to make this understandable, we have to look at how we got our final velocity. We got our final velocity by using the initial velocity, acceleration, and we also used time. So here, guys, it means that whatever that happens to the mass will not affect the final velocity. So the final velocity has to remain the same because we don't need mass to calculate the final velocity. And you can see from this equation of motion that mass is not what we need. And we are using this equation of motion because of what? The object happens to be in free fall. And if it's in free fall, we know that it's gonna only have us use the constant gravitational acceleration. And this means that mass does not change anything. There is something that can change our final velocity. What can change our final velocity is the height. You see here what they said. They said that this is being dropped from the same height. But if the height were to be changed, then we know that there is that, or rather there are those equation of motions that have height. If we were to change height, then height would affect our final velocity. I hope we understand that, guys. So this means that if we were to change height, it would also obviously affect the time, because more height means more time for the object to get to the ground. So time can also affect the final velocity, but only if the height is changed. However, velocity has no effect on this. Okay, velocity has no effect on this. So that's how we should answer that question. Obviously, guys, I'm not gonna put it in writing. Please take what I've said and put it in writing. Okay, but I hope you understand what I'm trying to say. And that is it with this question. I'll see you on the next one. Bye bye.